I know some folks think that surround sound is about adding extra loudspeakers. Unfortunately, that is not the case. It's a technical chess game between wavefronts, psychoacoustics, and decades of engineering. Today, I'm going to walk you through some of the tech, the history, and what actually matters at playout. Let's see what we have. Let's start at Bell Labs, 1930s. Steinberg and Snow tried to answer a tough question. How close can we get to perfectly recreating an original sound field with a finite number of channels? The ideal is infinite microphones, infinite speakers, every direction captured and reproduced. A full sound field synthesis. Impossible then and still impossible now. The experiment, they used 3 omnidirectional microphones, each sent to its own loudspeaker, and their findings that with 3 channels, listeners reported a stable, realistic soundstage. Dropped to 2 channels, center images completely collapsed, spatial width increased, everything sounded less anchored, less definition, if you will. Why is that? One of the critical things they noted is that our perception of direction relies on arrival time and level difference, often dubbed as ITD and ILD. The first sound that reaches our ears wins, so with careful timing and spacing, even a few speakers can fool your brain. So this was the first crack between sound field synthesis, or recreate reality, if you will, and stereophony, creating convincing illusion with less speakers. Big rooms, big problems. As rooms get bigger, the problems get bigger. Imaging falls apart as you move off-center. As you probably know, that with 2.0 or with stereo, it only works well at a sweet spot. On axis, dead center. For cinema applications, the solution was to try and use 3 front channels, left, center, right. Left and right to give width, and for the center, to anchor the dialogue for all seats, to stabilize the phantom center that fails in wide auditoriums. In 1939, using Disney Fantasia, an interesting experiment was done, dubbed often Fantasound, using multi-operator mix desks, pilot tone control tracks for dynamic panning, and yes, a ceiling voice of God speaker. The tech was a custom 35mm optical tracks to control the routing and amplitude of 3 audio tracks to as many as 54 speakers. Psychoacoustically, panning was continuous. They could create the illusion of sound traveling, not just jumping between speakers. The biggest takeaway from this experiment is that cinema isn't aiming for perfect realism. It's optimizing perceptual impact, hyperrealism, if you will. Sound that draws attention, emotion, and engagement. In the 1950s, stereo mixing hit the cinemas, but it was a mess. Dialogue was panned to match on-screen movement. It's hard to do, it's error-prone, and it was very time-consuming. 3 front channels became the standard for most of the industry. So what about surround? Enter Cinerama. 7 discrete channels, 5 across the screen, 2 surround. It required 3 synchronized projectors, 7 playback channels, an early prototype or today's immersive sound. Early surround used matrix encoding, combining multiple channels into 2, then decoding back out. The problem was that channel separation was weak. Crosstalk, steering errors caused bleed. Sounds appeared or leaked in the wrong spots. In the 1970s, Dolby's released matrix encoding. It used phase shifting and steering logic to try and fix this, but there was always trade-offs, as you can imagine, between separation and stability. At the time, researchers also experimented with amphiophony, using additional sound speakers to radiate reverberant ambience energy into the room to improve envelopment. The approach recommended separate ambient speakers for enhanced depth, and the commercial push came in the 1970s. Starting with quadraphonic. It was 4 channels, front pair, rear pair, often with no center. And the 424 encoding squeezed 4 channels into 2 for media like LPs, then decoded on playout. The downside was no center anchor, a hole in the middle. Speaker placement was at 90 degrees angle, so it clashed with optimal stereo, and every manufacturer had incompatible matrix systems, SQ, QS, CD4, etc. The rear channels were often matrixed, not discrete. Lots of crosstalk, unstable imaging, and phantom effects. And 4-track tape recorders tried to make quad work, but the consumer market never really picked up. The leap happened in the 1990s. Dolby Digital, DTS, SDDS, these were kind of the first practical way to send discrete, full-range channels, no matrixing, no phase tricks. The 5.1 standard, which has 5 full-range left, center, right, SL, SR plus low-frequency effects, came into effect. Driven by the ITU, it's BS775, the first version only defined speaker positions, not mixing rules or encoding. Engineers now decide how to use that sound field. And as you can imagine, that .1 is for the LFE. It is of limited bandwidth, it's just for effects and typically cut anything higher than 120 Hz, not a full-range channel. The advantages of this approach is, of course, reliable separation, stable imaging across all seats. Digital formats also allowed extra metadata for channel assignment, dynamic range control, and dialogue normalization. Enabled home cinema to finally deliver cinema quality surround. Modern surround has evolved since then. So it's not just about more discrete channels anymore, it's about objects and sound fields. Some of these are Dolby Atmos, DDS-X, and Mauro 3D. Mixers assign sounds as objects with XYZ coordinates, and renderers dynamically place and move these objects, adapting to the actual speaker layout, even with height channels. So effectively, the format is speaker configuration agnostic. Overhead speakers or virtualized equivalents at the vertical dimension, 3D soundstage, if you will. The benefits of this is provides flexibility for different room sizes and speaker configurations, and more accurate and precise localization with more immersive movement. There are still some psychoacoustic tricks, if you will, and some of these concepts were built upon the early experimentation we talked about. So you see, surround sound is not just about a gear race. It's a blend of psychoacoustics, deep engineering knowledge, and decades of creative experimentation. So whether you're designing cinema, mixing for streaming, or just wondering why your center channel matters, now you know a little bit of what's behind the magic. If you like these deep dives, like this video and subscribe, and maybe share it to help teach somebody else. And if you have a technical question and want to see a different topic, drop it in the comments. Thanks for watching.